Hello 108 students, Mr. McHugh back here with you on section 9.4. Going to tackle page 2 and we're going to work a couple more, one more problem where you solve for a variable. And example 2 has us looking at an equation that says s equals 2t squared plus kt. Okay, now they ask you to solve for t. So here we go. You know my recommendation is to say find the variable, go like that, and look at it. T squared and t to the first. What does this look like to you? Hopefully you're saying a quadratic equation. Okay, and if you're saying a quadratic equation, the variable t, the one you're supposed to solve for, if we put it in a standard form of ax squared plus bx plus c equals 0, we can make some substitutions. Okay, and so what we do here is the first step is to realize you move the variable s. In class, I caution you, the book loves to pick this variable because people like me come around and my s's look like what number? You got it. Look like a 5. And the next thing you know, you're combining s's and 5s and you're in a world of hurt. So subtract s on both sides and you have 0 equals 2t squared plus kt minus s. Okay, fine. You're still supposed to solve for t. I'm recommending that you do is look at the alignment here. Write the quadratic formula like I did and look what a is 2. Look what x is t. B is k. X is t. C, the constant, is also the variable s. And that's what I put over here on my table. Okay, I listed them like that. And you go, okay, that's great. You move the s term over. It's a quadratic equation. How am I supposed to solve for t? You pretend it's an x, and all you're going to use is the quadratic formula. And again, I encourage everybody to write this every time you use it. Now, one little note, use the form in the book. That's how the answer's they're going to like it here because you're not going to do a whole lot of number crunching here. So instead of x, t. Instead of b, negative k. Instead of a is the number 2. Okay, b is k squared minus 4a is 2 and c is s. Do a direct substitution from over here if you like your table. I like to use that. And simplify this the best you can, and you don't have a whole lot to do. 2 times 2 down here, there's your 4. Negative 4 times 2 is 8s, and basically there's your answer right there. Okay, now you've got to do a little bit of work when you put that into MyMathLab. You've got to break up that plus or minus, and I apologize for that. I just wish MathLab would fix that. Maybe in this new version that we're all waiting for, it'll be in there. I'll have to go check it. Okay, so now we're cruising. We're looking at objective 2, and now we're going to start some application problems. So I think this is the exact. Hold on a second here. Yeah, it's still example 3. It's on page 524 in your book. Okay, so here we go. I love this problem. I pick on 2 students. They tell me they got this story. They're leaving CWI. They're leaving Boise. One's going directly north. Going to go head up to McCall. Just pretend with me here a little bit. The other student is going west towards Oregon, and they leave at the same time. And all of a sudden, they stop. They're so far in, they stop. They realize. I make up a silly story. They forgot somebody has something in the other car, and they got the wrong kids, some silly thing like that, and they stop and they both call each other. And with the age of technology and iPhones and GPS systems, they discover through GPS and the app. I love saying that. I don't have one yet. My wife has the iPhone, and I have an old-fashioned Alias 2, by the way. But my cool thing is I would show you in class I could flip it up or sideways to do traditional cell phone, flip phone, or texting. But that's so old school now, it's unbelievable. Nobody wants those things. So iPhones are used by everybody, and they know they are 100 miles apart. Their GPS app tells them that. The problem is they both forgot to set the odometers, and they can't figure out how far they are, where they should meet. Should they go back to the starting point, or should they meet maybe somewhere on the diagonal? Okay, so in the problem, they tell you that the person going north was 20 miles farther than the person going west. or one from the other. And that's that relationship. So your MSI hat's on, you're dissecting this, and all of a sudden you go, wow, this is the Pythagorean theorem. I might have, the way I drew the diagram, you might want to switch this here, but what's the story? The hypotenuse is always what class? Opposite the 90 degrees. The A leg and the B leg are the other two sides of the triangle. You must always get the hypotenuse. It is always, always, always the side opposite the 90 degrees. Okay, so make yourself up a diagram. Here's what I wrote. Here's CWI. X represents the distance of the person going west, the one we don't know the least amount about. X plus 20 was the other person, 20 miles more. They're 100 miles apart based on the GPS. Can we help them out to figure out the distance they are? Okay, so we use Pythagorean theorem. C squared equals A squared plus B squared. What are we saying? The hypotenuse squared equals the first leg squared plus the second leg squared. Okay, hopefully you guys have burned that in your head. The hypotenuse is what? Always opposite the 90-degree angle. So here's your 100 miles and you're going to square it. The leg A is the distance we're going. I chose the variable x. Okay, look, if you wanted to use the letter A, you could, but the dependency is what you got to get for the second leg. That person is 20 miles more. X plus 20 quantity squared. Okay, and we have to pause and wait here for a second. We have to wait till page 3, so I feel like I'm running a commercial right in the middle of all these reality shows where you're waiting to see what the cliffhanger is going to be. So stay tuned. On page 3, we will answer this and figure out just how far apart the person is going in the horizontal position or X direction, and of course once we know that, we know what the person is going north. Okay, Mr. McHugh, going to sign off here now on page 2, and I'll see you back to solve this mystery and this riddle of how far apart the two riders are. Okay, take care. Bye.